Friday afternoon, folks, here in downtown Honolulu. Ted Ralston, your host at ThinkTech Hawaii. On our show, we bring you about the future of Hawaii called Where the Road Leads. And we'll be talking today about how to visualize that road, how to understand the terrain ahead, how do we inform the future so we can create that road and design where it's going to go. Got some exceptional guests here. This show, as you know, is defined by the guests we bring on. And I can't believe how great a panel we've got here today. Let me start from our cohort in California, John Mullen from Promia Corporation is our cyber expert. He's standing by on Skype. At the table here in Honolulu, we have Ro Bailey from the University of Alaska, who runs the Alaska, Hawaii, Oregon, Iceland, Pan-Pacific UAV Test Range. Got all that? General Wong, Darryl Wong, Air Force here in Hawaii that you've seen half a dozen times before in our show, our visionary leader in terms of where the future is all about. And then Skip Vincent out of Kailua, but also out of Washington, D.C., and retired out of the Air Force, who we've had some of his people on the show before talking about soft power and how these non-kinetic factors come into play. Our subject is going to be UAVs, which is how this show actually started about a year ago with Jay's interest and such. We've got a couple of artifacts on the table here just so we don't lose track of our subject of UAVs. It's a really interesting and evolving subject. We've had a lot of discussions this week. Ro Bailey is in town for that reason. And let's turn to Ro first as our first speaker here today, and just talk a little bit about what the status is, Ro, if you will, of the Alaska, Hawaii, Oregon Consortium, where that's going, and how we can socialize the value, the good aspects of UAVs in through that
okay, so you're going to give me the whole hour, huh?
Well, I can guarantee you Zuri will adjust that along the way here.
Okay. So the Pan-Pacific UAS Test Range Complex was crafted to answer and propose to the Federal Aviation Administration that we be one of the 6 test sites that they had been directed to establish by Congress in the FAA Modernization Reform Act of 2012. And we did our proposal process. We teamed up with Hawaii and Oregon initially, and a variety of other non-principal, those are the principal partners, and submitted our proposal, waited breathlessly for 10 months, and got selected. There were 26 proposals that went in, so we're very honored at having been selected. And so the idea is that the unmanned aircraft industry and the proliferation of these systems has grown so fast, the FAA hasn't kept up. And there are a number of challenges that they face for safe operation of unmanned aircraft in the National Airspace System. And so the mechanism they're using in order to develop policies and procedures and test technologies and establish certification standards for these systems is these 6 test sites that we're a part of. So the way that we operate, that we are operating, is as closely coupled but independent to some degree. We'll all follow the same policies and procedures that we develop for our operation. And we're going to do that following what the FAA's current rules are as closely as we can. That is, we're going to write new manuals and so forth that are closely aligned with the way they establish a new Part 135 operator, but we're going to tailor it so it fits into the unmanned aircraft world. And so one piece of it is getting it to the point where the systems are known to be safe and airworthy, and the procedures are available so we can interact with manned aviation without creating any risk to the manned aviators or to people on the ground. Pretty much everybody here is part of the flying public, and obviously none of us want to be in a position of being in the first aircraft that has to do something sudden to avoid an unmanned aircraft. And we don't want to be part of the group that creates that need for an aircraft either. So it's important we get these rules figured out. So one of the things that we bring in this new world of small unmanned aircraft is the opportunity to collect data and to provide services for those areas where either the area is dangerous, access is denied for some reason, it's very dangerous, like flying over a volcano, or the cost of doing so frequently is so high because of the risks associated with it, that we can get out there and do it for far, far less. And so a couple of the systems that Ted brought here kind of illustrate it takes a lot less money to put one of these little systems in the air, go out and collect the data and come back. And if it happens that something does happen and it goes into a volcano caldera, or it goes into the lava, or it goes into the ocean, you've lost a piece of equipment, but nobody gets hurt. And that's the most important aspect to me, is you're able to go out and do things and nobody gets hurt. There's dozens of other uses. It can help farmers with precision agriculture. It can help identify invasive species. It can monitor wildlife. It can monitor ocean-going mammals and even fish, whales, all kinds of things. So there's many, many different beneficial uses. So part of what we need to do is get out and show people what we can do. Hilo is doing a great job of that right now with the lava flow over at Pahoa, because they're mapping and being able to show literally week by week how the face of the earth is changing as that lava flow is going. So that's a few of the ideas.
That's a gigantic story you've told here. This goes everywhere from A to Z and everywhere in between. So we're talking about thinking of these UAVs as a system. We always get fixated on the airplane itself, but there's the sensors, there's the analysis, the software, and the information being fed to command personnel to figure out what to do now that we've done that, and reset and recycle. That's a really important part of this. The socialization that you mentioned, that may be the hardest task here of all, in terms of really getting the value statement down to something really concise that people can understand and see how it applies to them in their own lives. And we got to get it right so that we don't have any backfall on us and anything coming backwards. But data services, as you mentioned, value to the public, enhancing our understanding of what we're doing in our life and painting that road ahead is what this is. A fascinating opportunity to be at the cutting edge of this, at the very leading edge of it. And so we've got General Wong, who is many times been on this show and talking about the big picture of how these things all tie together into the environment, into the preparation for potential issues here that we face in this really extreme environment called Hawaii, or the extreme environment called Alaska. And we've got to find some way to bring this into the understanding of the people at really at the K-12 level, to get them started to accept and help us socialize forward. What do you see we can do, Darryl, to work with the state agencies and such, and start getting a little bit of a foothold in there?
I think to kind of piggyback on what Ro was talking about is the value of these things versus the negative things people hear about it. So, and it's purely just a platform, and you can put whatever you want on it, which is the beauty of it. And as she says, the business case of it's cheaper, no one's life is at stake if it does go into a danger area. There's a lot of different things you can put on it. One other thing you could add is even communications. So they're even looking at that as a mid-level way of expanding communications. They're giving you redundant communication in time of a natural disaster. So it's people understanding the value of what these things can provide in different types of their lives and parts of their lives, vice all the negative things that they may hear about, the term of drone, or, these are purely really remotely piloted things. And I think, being a pilot ourselves, there is technology that can deconflict this with airlines. And it's just a matter of integrating technology into this. Things like TCAS, a lot of different things, just altitude separation, a lot of things.
That's a really interesting point, and that comes back to me as a comment that Jim Williams made. He runs the UAV directorate at FAA. He said, interpret that term and that obligation we've got in the FAA of aeronautical research, interpret that as widely as you can. Go beyond the airframe, go beyond the command and control, go into the sensors, go into the tasking of how you would actually task something like this and then collect its information coming back. Think broadly, and we'll help you all go forward in that way. So in the work that you've been leading us in here, we can identify task areas where we could put UAVs to work, such as in Waimanalo, where Margie and I live, and start small, but learn as we go, and have that sort of thing, the applications built into our state work, not just the certification piece. Let me turn for a minute to Skip. You've been working the world in the last 5 or 6 years, solving problems that no one else has been able to solve in the world of soft power. And you've got a quite wide view of what humanitarian assistance is all about. Skip, how do you see something like this capability playing into the world that you've been dealing with?
Well, I really like what Ro and General Wong had just already said here, because what happens, every community has its own strengths and weaknesses. And there are gaps they have in their capability, which might be every day, but some of these gaps become apparent during disasters or during responses. And what I look at as an answer, as a leverage to the answer, is technology. You know, the real answer lies with the leadership and the people and the culture, but sometimes the only way to stay ahead of the event or to, you know, to bridge a gap that the community has, especially in a need, is technology, and I see UAVs as being a big part of that. General Wong talked about communications. You know, when communications are down, when there's a gap in communications during disaster, or even just to sustain part of the economy, isolated farms or the like. These UAVs, these UASs provide a tremendous capability. So from where I'm looking at things from the soft power point of view, I'm looking at communities and the community resilience. Where can technology help leverage the needs of the communities? And especially during disasters, when some of that technology and some of that infrastructure, at least for a time being, would be either ineffective or destroyed, these UAVs can actually save lives.
So we could actually take your kind of need statement and the vision that General Wong's got and tie it to what we're doing at the state site level, and begin coming up with tasks that really have meaning to the people in the community, in the county,
Exactly.
in the state level here in Hawaii and Alaska and other places.
And I can tell you, we've actually done some exercises with search and rescue, and temperatures 30 to 50 below zero, where it was an exercise, and so it was supposed to be a major aircraft exercise, crash, and in Bethel, Alaska, and they had victims scattered out over the landscape. And with our unmanned aircraft, we found all the victims in about 2 hours. The ground searchers took 12. At 30 to 50 below, they'd have been dead.
Yeah.
But we found them in time that we could have brought them back and got them saved, of course. Similarly, we've done infrastructure inspection on a major earthquake exercise where you go out and look at roads and bridges and approaches, and you can't fix them or deliver parts, obviously, but what you can do is provide information back to those who want to deploy the very limited number of civil engineers and repair people, so you can deliver them only to the places where actual repairs could be done. And so you're able to identify where you can restore transportation and potentially communication lines much, much more quickly. So it's not a solution by itself. It's a component of the solution to the kind of issues that you're talking about, Skip.
And the framework that runs underneath that, or rides on top of it, I'm not quite sure which, is the whole cyber structure that all of us, like it or not, have fallen into. That's what we depend on these days. Try living a day with your cell phone not working or email not working. And we have John Mullen on from Promia in San Francisco, who is a specialist in the understanding of the evolving cyber networks and such. And we always turn to John for an opinion on these issues because we always devolve down to the point where we've got a cyber framework, and information nodes are generating information that goes into that cyber network. We've got to extract out of that cyber network the information that's most useful, has correct latency, and isn't bothered by malicious input. So John, as this world expands and these kind of systems become more reliable and more distributed and smaller and end up being in more and more places, generating more and more information, how do you see us tying all that together so that we leave out the spurious and get the serious? How about that? Leave out the spurious and get the serious. And pull this together into information that's useful at the command level.
Well, thank you for inviting me, and thank you for these wonderful people being on the panel. I really appreciate the concepts here, particularly saving lives, particularly in Alaska when the temperature is so low. what we've been focusing on is interdiction of kidnapping, which is another interesting concept for the use of drones. And certainly we are all about the positive use of drones to help our society and our country. And certainly there's some negative use, et cetera. But we also, coming from the military side, we lock down all unauthorized use. And so, for example, we are promoting with a number of other companies in the United States, a CPU, an actual processor on all drones that has some control of the avionics, so that when there's any kind of short connection to another aircraft, that you have an autonomic response, as opposed to a human response down in a field-based environment. So we're certainly pushing that every way we can. Also, the cameras, we're pushing for privacy, but at the same time, we're pushing video analytics out to each camera, so that if you're looking for a certain license plate or something to interdict the kidnapping, you can very quickly, as you know, if you can interdict kidnapping, just like in Alaska, in a few hours, you normally save the life of the kidnapped person. So using drones for identification of perpetrators in this environment is very, very helpful. I certainly celebrate and appreciate everything everyone said, and also everyone's coming down to the concept of technology, and certainly we have to use it. As many of you, I can tell already on the list there, are from a military background. The only way to do this is formal methods. The only way to do it is extreme focus on technology and making sure no bad guys can come in and attack the things. But certainly we want to use the drones for the best benefit of humans in the United States and around the world. So I'm very happy and glad to be part of the team.
That's great, John. We're glad to have you on, and of course we'll see you in a couple of weeks up in San Francisco. We're doing a real exercise up there, Maritime Domain Awareness, with a number of organizations. John's system will be providing the framework of information exchange, and there's the UAVs. That one will be flying up there off an unmanned surface vessel under Coast Guard. Let John open up an issue here, and I think we all touched on it a bit, and that's the certification and the assurance that the system works like it should. And the issue that comes to my mind and intriguing, you mentioned formal methods. That's a very important part of this. How do we take informal systems that we've got here that came out of the model airplane business to a large extent, or to limited operation in the military, and turn them by formal methods into something that's large scale and yet still has the characteristics of doing exactly what it's supposed to do when it's supposed to do it? We'll talk about that in a minute. We'll take a 30-second break here and come right back, folks.
Aloha, I'm Hunter Hevlin, host of Sustainable Hawaii here at ThinkTech Hawaii. You can tune in every week on Thursday at 2 p.m. to see interviews with sustainability professionals from around the state and even further abroad, learning about activities with water management, food security, waste management, and a whole host of other fascinating opportunities to get engaged with making a greener island. So if you're interested in making the transition from consuming individuals to communities of producers, check us out every Thursday.
Back on, folks, Friday afternoon, downtown Honolulu, 4:26 in the afternoon. It must be ThinkTech Studios, Hawaii. It must be Where the Road Leads, our weekly program about the future of technology helping us with life here in the Pacific. Our guests are Ro Bailey, director of the University of Alaska UAV
Alaska Center for Unmanned Aircraft Systems Integration and the Pan-Pacific UAS Test Range Complex.
Do you think you could come up with maybe something really short, like
Aquasi and PPU-TRC?
That makes, I got that one too. That's great.
You've been doing this for a while.
Okay. And Ro's been telling us about how the states of Oregon, Alaska, Hawaii, and Iceland, which is not a state yet, are, and Google's not a state yet either, is it?
But, no, but they're working on it.
Yeah, right. And actually they're working on being the United States of America, a subset of Google. We've got General Darryl Wong on from the Air Force, and our visionary leader in Hawaii here, Skip Vincent. I like to say Kailua to take credit for Kailua being Santal here. who thinks big in terms of humanitarian assistance, and John Mullen, who thinks from our system perspective about how to tie these things all together. We're talking about UAVs, which we've talked about many times at this table. There's some examples here. What's interesting is we can show an example of an airplane. We can't show really an example of the system that ties it together. We don't have to think of how to illustrate that so that we don't get carried away thinking just about the airframe, but think about the value. The value isn't in the airframe. The value is in the information it provides and how quickly we're going to get there, which again we can't do until we have the system that ties it all together ironclad enough that it provides guaranteed performance. Not a lot different than the airlines today, where an airplane today is going to be around 50 years from now. I'm not sure that these are going to be around 50 years from now in exactly the format they're on here. John, we heard the story about the big picture, the cyber linkage and such. It's going to be up to us in the States really to figure out how to create the formal methods that generate that assurance. The intelligence people have something called equivalent assurance level, EAL, which defines how software behaves. We're probably going to have to think in those terms, which is something that I think the people who build these systems today probably don't think in. You're closer to that than any of us here. What's your thoughts on that, Ro?
A couple of things. First of all, for the people who don't know how aircraft get approved to fly, they have type standards. And so those standards say what kind of connectors have to be there, what kind of assurance of links, of communications, all those things are there. And so if you are a private pilot and you go buy an airplane, as long as you keep up with the maintenance manual, the FAA has declared that system airworthy, and you don't have to worry about it.
Okay? That's your 1952 Cessna 172. As long as you maintain that maintenance manual, that thing is good for 100 years.
That's well, and yeah, so stuff wears out. But
until
basically,
the aluminum gets eutectic and
there
it
you
doesn't
go. Yeah.
carry load anymore.
So with unmanned aircraft, on the one hand, we definitely want to get to standards, but on the other hand, what we don't want to do is constrain ourselves to the technology we see today, because the technology innovation cycle is incredibly fast right now. And so what we're trying to do is approach the concept of standards from, I actually like that term, assured, equivalent assured assurance value level, equivalent assurance level?
Yes.
Okay. I've been talking about it as a performance-based standard that says if the aircraft can meet the following standards, I don't care how you get it there, okay? I don't care what, are you using extruded aluminum or are you using extruded styrofoam? Doesn't matter, as long as it does what you say it's going to do every single time and it meets the minimum requirements that the FAA has for being able to safely operate in the National Airspace System. So what that means is the communication link between the aircraft and the operator isn't susceptible to jamming or spoofing or just interference from a lot of signals going on in the area, or even weather. Weather can be a problem. And the aircraft will stay in the air when it's supposed to be in the air, and it'll land when it's supposed to land, where it's supposed to land, okay? And it goes where it's supposed to go, and it doesn't go somewhere else. I mean, that seems very, very simple, but the reality is we don't have standards for those things quite yet. And so that's part of what we're doing with the test side, is to figure out what are the right ones, and then interacting with the FAA. Can you accept that way of thinking about it? Because this is the new way of thinking about it for them. So the idea of equivalent assurance levels, I really like that. I'm going to bring that up to our 6 test sites and talk about it and see what they think about that concept.
There's another thought we've had on this, discussion we've had on this show a few times, and that's the use of the supercomputers in Alaska and Hawaii as a way to model that environment where we can then run hundreds of thousands of cases a night. And I think John may want to make a comment about that. But to get that insight, we're going to have to get there quickly. Now, it took manned aviation, 80 years to get where it is, to 115 years to get, I got to subtract right, 109 years to get where it is today. That accumulated slowly. We've had a couple of major changes, turbines replacing pistons, aluminum replacing wood, and now composite replacing aluminum. Maybe 3 or 4 major steps, but even those took 20 years to get through. How many years we've been putting composites on airplanes? We still haven't got more than 75% composite. So the step change is tough to accommodate, and we're going to have insight generate very, very quickly here. I think massive supercomputing running all kinds of variations, cross blueprinting, maintenance changes, equipment malfunctioning, and human malfunction and such, is going to be necessary to find how to come up with those equivalent assurance levels.
Well, if we go back to the exemplary state concept where,
Yes.
Ro has talked a lot about the technology, but, even between the different services, the Air Force, people who fly the RPAs actually have some component of flying, because you have to understand the environment you're operating from. So someone that goes to somewhere and flies one of these things, when it goes up into the air, into the air traffic environment, you really need to understand what that environment is like. So has to be some training also of the operator, as you can see, up what level of training, depending on what areas in the airspace environment you're going to fly in, and then even the laws, the privacy laws, all these things. So it's going to take a lot of different things to get this thing approved by the culture of the United States people because of privacy. And if you talk to NYPD or LAPD, they're already using it, and they already have gotten through that. So taking best practices of large law enforcement that are already using these things in times of, when they use it. So they've gotten some through that privacy issue.
So you bring up the operational piece, and we've...
Well, because there's a human aspect of this.
Absolutely.
Thing.
So and that
And
includes
laws.
the ground station now, because the UAV is the pilot's not, there's no brains and eyes in this thing, it's on the ground where that occurs. So we could even, I'll go back to stump on the modeling thing, we could even bring that into the modeling component. And as you were talking, a thought came to mind that the National Guard here in Hawaii was understood well. Airplanes cruising at 35,000 feet, sitting up there cold soaking for 18 hours on a reconnaissance mission or something, if we had a long duration airplane, lands here in the tropical environment. What happens 5 minutes after the chocks are under, the thing's full of water, right? Because all the condensation's turned up. My guess that doesn't happen in Nevada or someplace. And so we're gonna have responses to the environment that people hadn't quite thought through. And yet our systems have to fight through that unaffected. So once again, I just think modeling and simulation is a way to introduce these variables and find out what happens. Let me turn back to John for a minute before we get to Skip. John, the whole issue of these really complex adaptive systems that are unlimited in dimension. Right now, as Rose says, we have no standards. We got to evolve those standards. If this was an explosion in the cyber world, how would you in the cyber world gain the insight as to how to create the standards and the methods by which you'll go forward?
Okay, well, thank you very much. First, I have to say there's really a whole wide spectrum of the unmanned avionics, and one of them are the little instant eye that we've been working with a lot. Another one is, I won't name the company, but for more than 5 years, they've been flying jets the size of our F-22s around the world unmanned, refueling in air, and doing all sorts of different kinds of things. So you've got a wide spectrum of kinds of devices, okay? But if you look at the human impact is like 2 or 3 different places. One of them is when the drone goes up in the air, it may impact another commercial flight, okay? That's one human impact. Another human impact is when the drone goes up in the air, it may stop and come down and hit somebody on the head. That's another human impact. So those sorts of things have to be mitigated through training, as you point out, but also, in my humble opinion, through avionics. So this is why I think, in my opinion, as you pointed out earlier, we aren't quite finished with the design of the tools. I think you're going to have fail-safe intelligence on the devices that say, when I'm coming too close to another device, when I'm coming too close to a flight plan, when I'm coming too close to something, I alarm, alert, or mitigate. And then if I come to a safety situation, like I power out and I'm about to fall out of the sky, I put a parachute up, a drone, a glide path, or something like this. I think you're going to have some intelligence. That's my opinion. Please don't take it more than my opinion, okay? But those are the sorts of things that we have to put in, and from a cyber point of view, you can certainly do that. We can, that's actually a very, very simple task, but we're going to have to, in my opinion, again, mandate from FAA or others that no drone goes up in the air unless it has fail-safe situations. And I mean, independent of the operator, independent of the human who's putting it up, independent. So it's got If the human says go here and it says I'm not going there because I'm in the path of a 747, it doesn't go there, right? And the same thing, if the thing runs out of power and runs out of battery and starts falling out of the sky, it doesn't hit a human head. So I'm sorry, but that's kind of my personal view.
How do you feel about that, John? So how do we take what you guys do in cyber in terms of modeling that or understanding the places where the weaknesses show up and how you fix them? How do you model all of that and gain the insight as to where the system has to be shored up? How do we take that experience you've got in the cyber world, and I mean you and the 1,000 others who do cyber, and bring it over to our attention in the state site world?
I might have a little bit of an answer for you.
Okay.
NASA has embarked on a project called UTM, which stands for UAS Traffic Management System. And the notion of that is to essentially establish the equivalent of an air traffic management system for unmanned aircraft, like that for manned aircraft in a controlled environment. And so they will be starting off with an airspace reservation system where you go on, it'll all be web-based, and you go on and you get your account and you sign on and you identify what your aircraft type is and where your airspace is, and it'll come back in the initial build and tell you, okay, you can't have that space because someone else has already reserved it. It's taken. Or they'll come back and say, well, you can have that airspace, but you've got a mountain in the middle of it, and you need to identify how you're going to fly and not impact that mountain because your altitude is low enough that you would. So that's the initial stuff. But ultimately, they want to get to dynamic positioning, dynamic control, such that if you're heading down, let's say that your desire is to fly down a pipeline. So you're a point A to point B kind of flight reservation that you want. But you know that you've got a route of a scheduled operation of some sort that crosses that pipeline every day at a certain time. So it would come back and say, well, you can fly it, but you need to hover at this point for this amount of time, or land and then retake off. Or let's say life flight now intrudes. This is going to be way advanced. So now you're flying down your pipeline, but life flight has now got a required flight. And so it can feed back to the unmanned aircraft operator, perhaps automatically into the system, and say, you need to reverse, move, get out of the way because a higher priority flight is coming through. And so this is a project that they're funded for, and they're moving down that path right now. And so I think it's a combination of modeling and simulation, real world testing, involving multiple volunteer manufacturers and suppliers of different sort, so that we can explore this. So we're getting the human side, we're getting the cyber side, we're getting the actual operational side, all happening in segments of demonstration, and then move along, and from what we've learned, they go on and develop more of that system.
And very quickly, perhaps much faster than it emerged and materialized in the last 109 years of aviation.
We can't wait that long.
Can't wait, right, so we have to move faster. After the break here, we'll take a 30-second break, but we'll get to Skip, because Skip has had a lot of experience in observing many, many human interactions around the world, military actions as well as others, and there's some common themes that emerge out of all of those. And I'm wondering how those common themes, which is how people behave, how people interact, and how people think, might affect the socialization that we're sort of dancing around here. So we'll get back to Skip Vincent as soon as we're done with a 30-second break.
Hi, I'm your host on ThinkTech Asia, Bill Sharp. I look forward to you joining us each Monday between 4 and 5 o'clock when we film right here in our studio in downtown Honolulu. The show, ThinkTech Asia, focuses on contemporary events in Asia. And by Asia, we mean anything from Hawaii, south to Australia and New Zealand, west to Pakistan, and as far north as the Russian Far East. Clearly, this is one of the most economically dynamic centers of the world, and we bring you up to date on what's going on in a whole host of countries in this very vital region. We look forward to seeing you. Aloha.
Friday afternoon, folks, downtown Honolulu. This is the final segment of our show for the day. I want to thank in advance our guests. Sometimes I get so excited I don't do that at the end, so I wanted to make sure that you got that now.
Thanks.
But, and John Mullen, I think, will be back in a moment here in our California studio. Anyway, I've got Ro Bailey here from the University of Alaska, Darryl Wong, Air Force, and Skip Vincent, once again, Skip from Kailua, and the rest of the world. But we're talking about the emergence of unmanned air vehicles into the world that we deal with. We're talking about the state of Hawaii and Alaska and Oregon and Iceland working together as one of the test sites where we can evolve the technology, the certification, the operations, the sensors, the payloads, the whole picture, which is really a daunting task. And thank God we have Ro Bailey running it for us, and that's a good thing. But I wanted to have Skip enter his views to the table here, because you've, again, analyzed many human social interactions, be they military or civil or peacekeeping or whatever they might have been. And some things have emerged out of that, as I understand, Skip,
It does,
that
it has.
will probably apply to us here.
Definitely, and I like the stories that Ro told about finding people in time, staying ahead of the dynamic events of a crisis, using technology to do that. But I want to go back to a couple of basics. One is leaders who are leading this effort, who are encompassing this technology and processes and responses, whether it's everyday movement of their running of their communities or a disaster, need to instill public confidence. And this technology here can do that very well. And before I go into that, I want to explain the concept of risk communications. And I found that risk communications actually brought things together as I worked in Malaysia and Burma and Saudi Arabia and so forth. But in stark contrast, during a disaster, you can actually have a group of scientists who had never met the community and people don't know, come up there and say, don't worry, there's only 1 in 20 chance you're going to die. And that, to them, that's a great statistic, but to the community, that's not. Where, in contrast, in risk communications, you build a relationship with the community. These are people that trust and know. They're trusted newscasters in Hawaii. Walter Cronkite, you know, in his day, a trusted individual, built a relationship with them, but also takes the metrics of the science and of the issues and puts them together in a truth. Because what the public is going to want to know is, what is the gap? Okay, where are we going? What kind of challenge are you having? What's the gap? And how can I be part of the solution? Mm-hmm. And risk communications has become a science, where it has been the difference between a community coming together with its leadership and accepting the dynamics and actually feeding the leadership examples or chapters of their experience so they can make better decisions. Vice one-way communications of a public affairs message coming down. This technology here, such as other technologies, whether it's a way to communicate over the airways or whatever, this kind of sensor enabling technology can actually help the community and help the leadership identify where they're really at, what the gaps are. And as that trusted leadership communicates it, has the community able to understand what they need to do and what situation they're in. And risk communications, which has become a science over the past 40 years, has been a phenomenal tool and an enabler to bring trust to the leadership and the technology that leadership is using. So the big thing is building a relationship with the community and the leadership so that there's an understanding and then there's a partnership on how we go forward and solve our problems.
That's a fantastic social idea to bring to the picture. That's part of the socialization. That's a great figure of merit, or several figures of merit. I can see a thermometer that says we're down here, but we have to get up here. Mm-hmm. But so everything we do in the state site we should look at it a little bit from that perspective as well. Have we really increased the confidence in the public that we got this thing right? Yes. And that they're going to get something out of it? Mm-hmm. That is we can't forget that. That's going to be a...
So the perception carries as much weight as, maybe even more than the metric.
Mm-hmm. So. That is, Skip, we'll have to have you at this table once a quarter at least, and keep making sure that is the way we're going. Because if that isn't the goal, if that isn't what's achieved, then we probably haven't gotten anywhere. Commercial aviation's got there, hasn't it? Because nobody even thinks about not getting where they're going to go in a commercial airplane these days. Even 20 years ago, you can remember people who were afraid to fly, right? They had these afraid to fly programs at the airlines. I don't think they have them anymore, to my knowledge, because it's become socialized and standard. And an airplane goes for 100,000 hours, and then you just do the service bulletins and send it out for another 100,000 hours. And they just last forever. The system is closes on itself very nicely, and it self-protects. We've got to get there and then have that trust come out the end. I like that,
May I
trust.
add
Equivalent assurance level and trust. Those two things they go together, actually.
Well, and the trust comes partially from people having the opportunity to provide their viewpoint into the conversation. And so, in fact, that's really what my whole trip here has been for the last 2 weeks, is to go around and figure out who are the key stakeholders, who needs to have their views included in what we do, who has special concerns like cultural sites, for example, that we need to understand what their concerns are and make sure that they're taken into account as we begin to do operations here, or anywhere. I mean, we do this everywhere. What do the airports and what does the local FAA think about what we're doing? I met with those folks at HCF today, and they were incredibly grateful. They said, most people don't bother to come talk to us. They just go do their thing. I said, well, but you can help me do it right. So why wouldn't I do that first? And so we have, just in one day, just in a short meeting, established the beginning of a trusted relationship. And that trusted relationship, along with all the other ones that I've begun to build with my team and with you guys here working on those things, what UH Hilo is doing, they've established an incredibly good relationship with the people of Pahoa because they know that they're there to help them. And so you talk to them, you figure out what they worry about, you bring their thoughts into the equation, you show them that what you're doing is in fact useful, so now you're backing it up with action. And that's what changes people's minds. They don't care so much about what you want, what you know. They want to know how much you care, right?
Can I mention something? Earlier in the talk, there's about 3 seconds of something that you had said and done. You talked about how the UAVs actually found somebody before it was too late. Mm-hmm. And I could hear the empathy in your voice, and I can hear the happiness, the fact that something else happened here. That is the kind of communication, that's the kind of relationship you need to build outside. People need to hear that and see that, and then they'll start to trust it.
That's why we're here at this table, because this is one way of public output, and if we're going to have to do a lot of this. Yeah. Let me see, we seem to have run the hour down, but let me just ask each to just give a 30-second statement of what you hope the audience might have taken away from this, so we can set the stage for next time, and we'll have to get you back here a lot.
Okay.
Let's start with you, John Mullen, if we still have you online by Skype.
Sure. Can you hear me?
You got you.
Yeah, okay, good. First, I want to thank you a lot. I've learned an immense amount in the last 15 minutes. But I do have one piece that I'd like to put forward for people to think about. It's a concept, it's called privacy by design, from a woman, Anne Kevorkian, out of Canada. Brilliant woman 10 years ago. And what its whole premise is incorporating privacy into monolithic systems, software and others. And as you put out the empathy of finding someone early, that's incredibly powerful. And I'm trying to do the same with kidnapping. But, one of the problems with drones is people's perception of invasion of privacy, and the same with software systems. And so we're working as hard as we can on Anne's top 10 formulations to embed privacy controls within the system. So I encourage, I know it's a little esoteric, but I encourage you to look at this, to embed and incorporate the privacy concepts into the technology as it goes forward, okay?
That is excellent.
Am I next?
Please.
Okay, first I have to address that, so this is going to be quick, but privacy is about how people treat the data that they gather. It's not about the tool that's used to collect it. And so while there may be some technological solutions that assist in that, the reality is some people will behave well and some will behave badly, and we need to deal with bad behavior, not the tool. The other aspect about this is that this is an exciting technology that gets a lot of positive attention and some negative attention, but it's really the same thing. It's all about how we use it and how we include people in the expansion of the use of these systems.
Thank you. General?
I kind of want to also say again, this is a platform, and it is a valuable platform into the future, and leave it at that, because it's how it's presented by the media. So as we talk, media can present it any which way, so you know, the value proposition of this thing and what Ro has talked about and Skip has talked about are the ones that really got to go forward and not use all these other negative things, because the value proposition outweighs any negative things this thing has been looked at. So if people just look at it as a valuable platform going into the future where you could put any types of things to help save lives in time of a natural disaster, that it is a beautiful thing going into the future.
Skip?
Technology like this is not the answer. Technology is the enabler. The answer is with leadership, relationships, and so forth, and how we interweave technology in that structure, that leadership structure in the community, rather than try to weave the structure in the community into the technology, is so critical. Where trust breakdowns and so forth get recovered very quickly, and dynamics of the advantage of technology and leadership move forward very quickly to solve the problems.
These are fantastic insights, and I'm going to think about these and how we can construct the next time that you're in town and we can get you back on here. We'll have to hit this ball a lot and take a lot of batting practice and bring other people in. And John and I will be together in a couple of weeks in California. We'll take this, look at that privacy issue. We'll talk about equivalent assurance as a way to measure some of these things. And the value statement that you bring in terms of the trust and the positive socialization. Fantastic thoughts. And at this point in time, we're going to get kicked out of the studio in a minute, so we've got to wrap it up. I wanted to thank our excellent panel once again. John Mullen in California, Ro Bailey here, General Wong, and Skip Vincent out of Kailua. And folks, we'll see you next Friday on Where the Road Leads. Have a nice weekend.